Good day, students. Today's our lecture is statistical principles. So, uh, after obtaining all of the results of the sensory evaluation, then we should uh, modeling. So this section look at the role of the statistics in the sensory evaluation and introduces some terms and concepts required to correctly apply statistical methods in evaluating sensory type data. So why do we need sensory in sensory evaluation statistics? So it's because this variation, there is some risk in making decision about changing formulation or introducing new products onto the market. Using statistics, we have rules to estimate and minimize the risk and enable us to extrapolate our results from an experiment to a more general situation. So when we are measuring some things like salt level in the cheese, we find there is a variation in what we are measuring. So this variation is called natural variation or experimental error, and implies that there is some true measurement, but because of our limitation, we can't reproduce the correct readings every time. So this is a fact of life, and we have limited control over the sort of error. And what's an experiment? So it's any process that generates raw data. So there is many sources of error in the sensory data. So some of this include as a difference between people, if they like or dislike, difference within person from time to time, or adaptation, difference among samples, difference interpretation of scales, and many more. So we try to exclude all of these mistakes. So looking at this graph or distribution, we ask, what is the best single estimate of the panel score and what a good measure of their variability? So the best or most likely single estimate called measure of central tendency. So we are taking in account of the frequency and flavor acceptability. We can distribute it. Okay, so how we can describe our data? So uh, it's let's say we have collected some data from an experiment, and we have 20 scores of flavor acceptability in a mango sample and rated on a 9-point hedonic scale. So if we plot or bar graph histogram using the score along the horizontal axis and count for a particular score, so and the vertical axis, then we have frequency distribution. An example is shown as an average or mean. So mean or average, it's the sum of all of the data values divided by the number of the observation. But medians, it's the 15th percentile or middle value, mode cost frequent value, what is good for categorical data. So measures variability include the range, standard deviation, and variance. And the range is simply difference between the smallest and largest. The standard deviation is probably most common and calculated by the using formula. So there is M is the mean average of the X scores, and the N is the number of the scores. So this formula calculated the deviation of each score from the mean, and squares it to take in the account. So positive or negative values, and the square roots then take to bring it back to original unit. So the variance is simply the score square of the standard deviation, and is used in a number of statistical formulas. So hypothesis in the sensory analysis, it's the in statistics a null. So alternative hypothesis is set, which is in turn reflects the objective of the problem and its solution. So a null means no effect and no difference. So it's the same. So example, there is no difference between of the means of two sets of the sensory score. So this can be written by mathematically as a So A uh, is like B. So alternative hypothesis is then there is a difference between the means of the two sets of the sensor scores. And H1 is A not equally to B, so it's the must be specified before the test is conducted. So if each one is formulated after reviewing the data, and the results of the statistical test will be biased towards rejecting the null hypothesis too often. So there is two types of alternative hypothesis, one-sided and two-sided. So one-sided is general whenever each one has the form as more than less, and before both of the specified confirm that the test brew is more bitter, or confirm that test brew is preferred to the control. For two-sided, it's a general whenever each one has the form A as is different from B, decided which brew is more bitter, or which the test product is preferred. So no statistical criteria for determining if each one is the one or two-sided. Depends on the prior knowledge or interests of a researcher. As example, it's there is a tomato juice samples with added salt where this tasted. So in paired comparison tests with the same juice sample and the juice sample without salt by an experienced judge 12 times. So the judge was asked to identify the saltier of the two samples. So is this or one or two-sided test? So in paired preference test, judge who could distinguish between two instantly effervescing chewable multivitamin capsule products A and B, and was asked which product was preferred if it is one and two-sided. Okay, so it's the task for you. And the type 1 and type 2 as an error. So in the sensor analysis, we significance of the making committing. So, for example, it's the test against the formulation and ensure they are not different. In this case, we are more worried about committing type 2 error and don't accepting each one when it is true, not saying there is differences when there is. So, should we deduce that we don't have a difference between the products? And when there is a difference, we would market the reformulated food when it had a different flavor from the original product. So after concluding, we can make a decision. So the consumers would notice this flavor change and stop buying the food, or alternatively, we may testing for desirable change and particular attribute. It means spiciness. So level of significance conventionally at 5%, and it's set up alpha 0.05 and can be 10%. It's about 0.1, and difference significant probably at the level of 5 means that the probability of getting result obtained if it is true. Yeah, so it's calculated by the probability, or if it is less or more than this point of the level. So it's, in this case, we would be more worried about type 1 error reject H0. So when it's true, saying there is a difference. When there is no difference, we would market this product being more spicy. So however, the consumer. So what is the last we can describe by the this schematically? What about the consumer acceptability, if they are choosing this or not? So why what is the panel setup should be, and this tree decision makes. Yeah. So if the sensory analytical question is probed, if you need other tests to approach. If it is not, so we are going to the less. Then choosing from the triangle procedure, dual trio procedure, dual standard, paired comparison, etc. So all of this making, then we can evaluate the testing. So thank you for your attention, and wish you good luck.